When I talk about overlapping objectives, sorry for this cartoon, but you know, our water users are interested in water supply reliability, and the carryover storage component helped. Carryover storage also helps with water temperature. I'm going to say more about that in a minute. And the modified FMS created a huge overlap in those interests. Okay, why storage? Why is storage important for temperature? Why did we start looking at storage? Excuse me. Well, a couple of reasons. One is that the 2013-2015 drought freaked us out. We came at basically in 2 times during that period, we came within a few thousand acre feet of what we call dead pool. 90,000 acre feet of storage in Folsom is a point at which bad things happen. I'll say more about those bad things in a minute. And we were, with the want of a couple of key storms in 2014 and 2015, we were going to hit there. People were literally talking about building a barge that would float in the near empty Folsom Reservoir in order to get water to some 250,000 people in the region. The other reason we started looking at storage is that we observed that it appeared that Folsom was being exercised more aggressively post the drought of the 1990s. This shows 2 time periods, 1960 through about 88, 1995 through about 2014. And you can see that the low point of the reservoir is 135,000 acre feet lower on average in the later period. You might ask yourself if those periods are comparable. Well, it turns out that both of those periods have nearly identical total average runoff during those periods. So they're really comparable in terms of water entering the Folsom Reservoir, but Folsom ended up lower in the later period. Now, changing demands has something to do with that picture. Demands did go up on average about 54,000 acre feet during that period, but that only explains a portion of the 135,000 acre feet drawdown. So the drought scared the crap out of us. Folsom appears to be being drawn down lower, and Folsom storage, just through casual observation, appears to be linked with temperature. I showed this graph before. 2016, a wet year, had higher storage, the river's colder. 2018, drier year, lower storage, warmer temperatures. Storage is also a big deal for our water suppliers, in particular, City of Roseville, City of Folsom, and San Juan Water District, the community of Granite Bay. Their primary water supply is something called the M&I intake. Those water guys have really, imaginative names for things, right? M&I stands for municipal and industrial. And it's basically a pipeline that hangs on the dam next to that temperature control device. If Folsom Reservoir gets below 90,000 acre feet, that thing literally starts to suck air. And about 250,000 people lose their water supply. And those 3 communities have very small alternative water supply. Roseville has a little bit of groundwater. Granite Bay can do some water training, not much. And City of Folsom, they're kind of stuck. So this 90,000 acre foot level we call dead pool is really serious. But things start getting serious even before you hit the 90,000. Below 200,000 acre feet, the capacity of the pipeline starts to fall down. It's a hydraulic system, and the level in the reservoir changes how much water you can shove through that pipe. Below 200,000, those 3 communities in total can't get enough water out of the pipeline to meet their peak summer demand. So low storage is serious for them. And dead pool in particular is serious. So we started this process of trying to develop a modified FMS with these 2 objectives in mind. Make the river better, try to avoid this 90,000 acre feet, this dead pool level in a modeling scenario. And in particular, we said, the worst drought period in our model simulation is the 77 drought. And so let's try to avoid that in a 77 drought. But keep in mind, we are putting, a future water demand overlaying on that. As we started this exercise, we remembered our uncomfortable conversation that we had with nymphs back in the 2015, 2013 period, where they said, don't sacrifice Sacramento River for the benefit of the American. And so we ended up in our modeling approach adopting a third objective, and that was no harm to Sac River fishery. And again, we did that by adding an end of December storage target. Okay, this next section is performance. This is not, and then the section after that is sort of what are the components, how does it work? Performance is, what does it do? How it works is how it does it. These are some of the things that we achieve with the FMS. I'm not going to read every list, but I am going to point out that one of those, the no impacts to Sac River fisheries, is something that we achieved by something we call tuning. This is a conceptual graph. The x-axis of the graph is end of December storage, right? So we did a whole bunch of modeling. The thing that we varied in the models is the requirement for a storage value at the end of December. Model scenario 1 might have said make 285. Model scenario 15 might have said 400,000, right? So we did a whole bunch of scenarios. And what you see with those scenarios is that the higher you make your end of December storage, the colder you make the American River, and the better you protect storage in Folsom, right? Higher storage, the more you protect storage, kind of a no-brainer. So as you go to the right on this conceptual curve, the benefits to the American River, both eco and water supply, they go up. But you also see that as you go further to the right, you basically start to sacrifice conditions on the Sacramento River. Folsom and Shasta are basically a teeter-totter. If you protect storage in Folsom, to some extent, you have to draw some storage from Shasta. If you draw too much storage from Shasta, you will endanger their ability to do cold water management on the Sacramento River. And we've been told that's just not acceptable. In doing this tuning process, we basically found a sweet spot. And we discovered that at 300,000 acre feet, end of December storage, there was de minimis, unmeasurable impact to Sac River temperatures. Here are some exceedance graphs. These are the results of 82-year modeling simulation. The way these models work are, we have a digital representation of a physical system. We overlay current regulatory schema on top of that and future water demands. And then we play with different flow standards, right? So everything held the same. And then in order to get to simulate the variety of hydrology and weather that we get, we take a historic weather tracing, 1904 through 2003, I think, an 82-year simulation, and we run it through. This is the end of November storage over that 82-year simulation, and you can see that the old flow standard, the 2006 FMS, hits dead pool 2 or 3 times over 82 years, unacceptable, whereas the modified FMS not only doesn't hit dead pool, it actually has a little bit of a buffer. I choose November for this because it's always the month where storage hits its low point. This shows one of our principal environmental metrics, water temperature at Watt Avenue in August. There's a similar graph with a similar relationship for July, September, October. And basically what you see is that the modified FMS is colder. The optimal temperature is 65 degrees. And and by coincidence, actually, both of the graphs are essentially the same below 65 degrees, but above 65, the 06 FMS is always warmer. And those curves may look really close together, but from a biological standpoint, there's a huge difference between them. The blue curve, a biologist would tell you, is a significant improvement over the red curve. Not only is it cooler by a half to 2 degrees over 35% of the time, at the upper end, The red curve is near certain death for salmonids, where the blue curve is unhealthy but not fatal.
And Tom, that curve also illustrates the fact that the FMS does not optimize conditions for fisheries in the Lower American River.
That's right.
A significant number of years, conditions are unfavorable to lethal, even with the modified FMS.
Yeah, it's kind of like, we think this is the best you can do. It's still not great. Yep, thanks, Ron.
Well, it's the best we can do, tweaking with the dials that
With
we
those
have.
dials we have, yep, you're right.
One can try to find other dials, including other physical improvements
Yep.
or modifications of the demand profile, particularly in the Sacramento Valley.
Thanks. We also looked at habitat, the red curve, 06 FMS, the blue curve, modified FMS. We actually have a modest improvement in spawning habitat for fall run. Here is Shasta storage. There are actually two curves here, a red curve and a blue curve, but they are so similar that you can't tell the difference. I have a similar curve that shows temperatures in the Sac River over different periods, and I think I've neglected to put it back in the show. But basically, when using the model simulation, temperatures are essentially don't have a measurable difference with this modest what I would consider a modest storage protection at Folsom. It also turns out that not by design, but because of the way the system works, if you protect conditions at Shasta, through our tuning process, it turns out that the regulatory requirements for salinity and delta outflow are so strong in the system, they're strong, the force is strong in them, that a result is that you basically won't end up hurting exports either. This shows that, de minimis change in exports over the simulated period. What about unimpaired flow? The reason we ask this question is that staff at the state board have used unimpaired flow as an objective for environmental flows for contribution to the Delta, both in the San Joaquin River watershed and the Sacramento River watershed. And it turns out that on a block of water basis, if you look at the 72-year simulation, and you look at the outflow from the American River during a February through June period, we meet always are at least 46% of unimpaired flow, oftentimes higher than that. Within those months, we do dip below 45% sometimes. A scientific basis report from state board staff, that's about 2 years old now, called for on a monthly basis, unimpaired flow of between 45 and 65%. And then it talks about, under some circumstances, you can look at that as a block of water basis. So here we look at this as a block of water basis, February to June. We're in the range of acceptable, right? There's a lot of nuance here about what the state board is specifically looking for. So I don't want to give you the impression that we're just good, but at least by one metric, we're not way out of the realm of acceptability. However, from just an American River standpoint, an unimpaired flow approach actually creates harm from a temperature standpoint. Basically, if you force 55% unimpaired flow every month during the spring, you use so much storage from Folsom to maintain that flow that you basically blow out your cold water pool. And our modeling bears that out. So in previous conversations we've had in the VA with state board staff in informal discussions about delta flow criteria, we have pointed out that we think that our modified FMS is environmentally superior for the American River, right? And then there's a follow-on discussion about, okay, well, how about meeting your fair share contribution to the Delta? So This is the connection. Greg, I think you asked about connection with water quality control plan and the Delta and the VA. This is the connection. There's this conversation about how does this basin provide its contribution to the Delta, but how do we also sort of maintain a suitable water temperature here? Okay, how does it actually work? What are the components? Bennett, how am I doing for time? Am I okay? I have 10 more minutes.
You're doing okay. You've got, I mean, we're going till 10:30. So
Okay.
if you go for 10 more minutes, we got still 20 minutes for conversation.
Good. Okay, how's it work? It's similar to the 2006 FMS. The temperature management approach, the American River Group, which is a stakeholder group convened by Reclamation, and our approach to monitoring and evaluation, they're all the same. We have a minor change to the approach to minimum flows. And as I pointed out before, the end of December storage target is new. I just want to point out that the FMS is designed to meet these biological objectives. You know, it's really easy to forget your underlying objectives and just think about the mechanism, right? And so I think it's important at this point to stop and say, we are trying to support each of these biological objectives. It does have this technical underpinning. Okay, minimum flows. Minimum flows are designed to try to provide as much spawning habitat as possible given the available water in the watershed for the given year. I talked about the fact that habitat changes with river level. This is the flow habitat relationship for the American River. On the y-axis is a unitless representation of habitat. This is actually percent of maximum habitat, and the x-axis is flow. A couple of things you'll notice. Optimal spawning habitat for both steelhead and fall run at 2000 CFS. To the left of 2000 CFS, you have less habitat, and to the right of 2000 CFS, you have less habitat. However, when you go lower than 800 CFS, the habitat quantity quality falls off precipitously. Above 800 CFS, you basically have 80% of the available habitat. We've designed the minimum flows so that 96% of the time being our 80 years of simulation, 96% of the time, we have at least 80% of the available habitat. But in some years, there's just not enough water in the watershed to provide that amount. Here's a difference. So first of all, let me talk conceptually about the way the minimum flows work. Minimum flows are a sliding scale, both the old FMS and the new FMS. And so that as you move to the right on these conceptual graphs, a wetter year, the minimum flow eventually gets up to the point where it's 2000. There's enough water in the watershed, you will give us the optimum flow for spawning. But in drier years, we recognize there's just not enough water to do that. So there's kind of this sliding scale. With the old FMS, the sliding scale bottomed out at 800 CFS. And below that point, the old FMS basically disappeared. And the regulatory requirement for flows defaulted back to the old water right decision called D893, which is from the 1950s, right? Which allows flow in the river to go as low as about 170 CFS. The new FMS actually has a lower floor. It goes down to 500, but it's an absolute floor. You can never go lower than that, at least for releases. Now, this is a release requirement, not an in-stream flow requirement. Other differences, the new FMS has a different index for measuring hydrology. I'm going to say more about that later. And the new FMS has a pulse flow. Also, the new FMS has something called red dewatering adjustments. It's super wonky and technical, and I'm going to talk about it conceptually, not go into detail. These are the actual minimum flow curves for the modified FMS. You can see that they're different for different times of the year. They have these different inflection points. Those inflection points, the shapes of the curves, were developed through hundreds of iterative modeling simulations to try to meet our objectives. Better temperature, don't hurt habitat, if possible, get more habitat, avoid the super low flows, avoid hurting the Sac River. So it was part art, part science, getting those curves. These are just sort of adjustments. I'm not going to go deep into this, but the 06 FMS had a bunch of adjustments. Most of them were proposed by Reclamation as a way of protecting some of Reclamation's operational imperatives. The only adjustment in the modified FMS is to attempt to avoid dewatering of reds. This is some detail on the red dewatering adjustments. The takeaway here is that we embedded in the FMS a method where in a year where if the year appears to be getting drier, we started out in January and it looks like it's February and it looks like it's wet. And then we go to March and all of a sudden it stopped raining and it looks like it's drier. The hydrologic indice would say drop your minimum flow. Doesn't say to Reclamation that they should drop their actual flow. It says that their minimum is lower. We put limits on the drop of the minimum to try to avoid dewatering of reds. Okay, a word about the indices. The old FMS had 3 different indices, the Sac River Index, which we still use, and then it had something called the Impaired Flow Index, and then something called the 4 Reservoir Index. The FRI, the 4 Reservoir Index in particular, was seen as a problem to some stakeholders. Some stakeholders pointed out that it created at least the perception of a feedback loop, an unwanted feedback loop. In essence, because the flow standard doesn't say anything about how high Reclamation can have their releases, someone pointed out that Reclamation, if they were devious, and I'm not saying they are, this is all hypothetical, right? If they were devious, they could release a whole bunch of water in the summer, which would lower storage in the 4 Reservoir Index, thereby giving them a lower minimum flow in the fall. Some people called this potentially gaming the system. So we wanted to take that perception away. So we came up with something called an American River Index. In essence, it is what we think is an effective measure of how much water is available in the system. It's basically DWR's measure of unimpaired flow for the season minus actual spills from Folsom Reservoir. We continue to use the SRI for January because that's basically the only index available to us at that time. Here's just some stats, tells you how good we think our ARI is. Moving on, we also have a pulse flow. It's a relatively modest pulse flow, from a biological standpoint. Some people would definitely call for something more. Through our modeling, we think that balancing the objectives of habitat and temperature and the benefits you get from a pulse flow, we feel like this is all we could afford from a water supply standpoint. This is kind of a mid hydrology pulse flow under dry and very dry years. Basically, this requirement is not there. We designed it so that it's a chunk of water in those mid-dry, mid to medium dry years, with the expectation that Reclamation and the fish agencies will meet and confer and talk about how to employ that block of water. So end of December storage target, it was, in most years, we did have exceptions for drought years. Again, purpose to preserve cold water pool, create flexibility, be sort of a drought reserve. But again, we have set that hard 300,000 acre foot aside to this thing we called that we are now calling a planning minimum. So the planning minimum concept is in Reclamation's current biological opinion. They proposed it in their BA. I consider that a huge sign of good faith to the Water Forum. You know, we had a verbal agreement with them that they would accept and implement the flow standard with this idea of a planning minimum, and that we would all try to ratify that agreement in an MOU. We haven't finished the MOU, but even short of the MOU, Reclamation wrote this into their biological opinion. We had not come to agreement on a value for the planning minimum. The BIAP says, I think that it'll be something between 275 and 300,000. But in our negotiations, we have tentatively agreed that 300 is the number that they will use, at least for a 3-year trial period. Greg, anything else on BIAP before I move on?
And Tom, just to catch up on time, you're starting to edge close to quarter after.
Okay, you got it. I'm gonna keep going. I'm gonna skip that slide in the interest of time. Temperature management is based on these optimal temperatures. Get as close as you can to 63 degrees in the summer, 56 degrees in the fall. And just a word about the philosophy of temperature management. On the American River, you could be very prescriptive on temperature management. The advantages of that is that the rules would be very clearly stated. But because hydrology and therefore achievable temperature is so variable in the American River, you would either need to have a temperature standard that's a high temperature, which wouldn't be very protective, or you'd have a low temperature, which would require, you know, frequent exceptions or violations. We've gone with something that's adaptive, right? It's adaptive. It's based on, you know, every year you have to collect information about how cold you can get, and as Ron would say, given the knobs you have available. It's really dependent on modeling, but it also means basically, you know, look, Reclamation has a lot of competing demands when they operate Folsom Reservoir. Competing demands for delta water quality, for exports, this seesaw, this teeter-totter effect with Sac Valley water supply and Sac River water temperature. So it is understandable that if we weren't here helping Reclamation support this temperature plan every year, it would be too easy for those other forces to pull Reclamation in a different direction. So this adaptive approach, I think it's superior because it changes with time, it changes with conditions every year, but it absolutely requires an ongoing investment from someone, and that someone has been the Water Forum, to continue to help Reclamation get the modeling right, make sure they're adhering to these objectives. Just really quickly, this is, you know what, I'm going to skip over these. This slide is a tour de force in terms of Tom Gohring PowerPoint animation, and it's demonstrating that how, as Ron would say, the knob you turn, which is the timing at which you pull the shutters, and eventually you've pulled all the shutters, and at some point you might need to bypass the power penstock to meet cold water. We did that this year. Temperature approach is based on a model. You take information about the system, how much cold water in the reservoir. It spits out the quote, the lowest possible temperature you could get for the given conditions. Why? And then again, there's this relationship. More water means more cold water, which means a colder river. Okay, summary. The FMS does all these things, right? At least during the simulation, it wouldn't. Look, we can't guarantee that we'll never hit dead pool, but the modified FMS tells us that we significantly reduce the chances of hitting dead pool in the future. We've got lower water temperatures. We've slightly improved Chinook habitat. We're avoiding what I call super low flows because we now have a solid floor below 500 CFS. Avoided impacts to SAC and other places, so that over time, we think the FMS makes us have less of this and more of this, both cold water and avoiding super low flows, and less of this and more of this. Okay. Remember I brought up this slide at the beginning and talked about implications for water forum 2.0. I've highlighted, at some point we need to talk about ongoing costs. I hope I've imparted why ongoing review of reclamation is important. I think that we've discussed a little bit the fact that, you know, some folks, and I'll throw Ron in this camp, have expressed interest in going to the state board, you know, in the future. We need to talk about adaptive management. The flow standard should not be static. And then we need to talk about how water forum 2.0 would plug into a state board or VA process. Next steps. Yeah, we got to talk about adaptive management. We got to talk about things like the California Environmental Flow Framework or other thing, right? That's the latest, you know, new shiny thing on flows. I guarantee you there'll be another one, right? I think we need to make sure we build on past investments. I would be extremely disappointed if we kind of tossed out what we've already done and said, let's just start with a clean slate. You know, and there's tension between those, right? Between honoring what we've done and being adaptive. We got to continue ops review. We got to talk about a future implementation mechanism, whether that's MOU, state board, or a new BIOP. And by the way, there will be a new BIOP, whether it happens in the next year because of a Biden administration, or it happens 5 years from now, just because they seem to happen at least every 5 years, there will be a new BIOP. And then we can't forget that there are other temperature management stuff. And when we get to the flow standard chapter, we need to make sure we talk about improving the TCD, other hardware improvements, reducing temperature gain across Lake Natoma, and then finally, got to talk about bringing this into the VA. End of show. Questions?
Thank you, Tom. Let's see if there are questions, and also, you know, obviously we're not going to discuss what the flow standard should look like, but really thinking about, given what Tom just laid out around flows and the lessons here, what does it tell us about what we need to think about in terms of the water forum 2, how we want to think about flows? There are other issues. So let's open it up. We've got about 10 or 15 minutes here. Again, I'll try to move around the different caucuses and also bring in folks who maybe don't weigh in quite as much. And just a reminder to folks who might have joined late, this conversation will focus initially on those who are here as primary members of the NSC, and then we'll also open it up to alternates. So let's, Rob, how about you jump in here first? You are on mute, Rob. Sorry, you're on mute again. You're on mute.
Sorry.
There you go.
What I'm not totally clear on is how changes or increases in demand within the American River Basin due to you know, demand for water are taken into account in the modeling of the effectiveness of the management of at the dam on river temperatures and flows. Does the increase in withdrawals by the organizations that the water providers that have access to the river, is that reflected in the modeling?
It is, and I'm going to say more about this in the next post break about modeling that I'm proposing we do as part of this process. But you know, for all of the simulations that we're talking about, we basically always do an existing condition and a future condition. Existing would be with current demands, future would be higher demands. And so we definitely look at that. Demand, changing demand has an influence on river conditions, obviously. However, in this watershed, because we only use between 5 to 15% of the water that leaves the watershed. We're basically, we're an export river, right? Our water goes to the delta and goes out. The changes in demand here in basin don't move the needle nearly as much as some of the other factors. Does move the needle, not very much. And as I'll talk about after our break, the modeling I propose will do just that. It will look at current condition, future condition, change demand, changed in climate change, because yeah, we need to understand that, how those things influence.
Thanks. Greg.
Yeah, thanks, Tom. Great presentation, really interesting. One just little addition I thought might be worth mentioning is you touched on just now an export river and the connection to the Sacramento, and that there's the American River Group. And I don't know if you want to explain a little bit more what that group does, but one of the things we've struggled with, or at least I've struggled with, is trying to get reclamation to explain a little bit more how the needs to put water into the Delta and the sort of trade-offs with the Sacramento, how that impacts the American. And, they started providing, when there were changes from Nimbus, they started saying, Delta needs was put in, but trying to get some sort of aggregation of the impact of meeting Delta needs from Folsom instead of Shasta has been hard to get. So I don't know if you want to touch on the ARG a little bit.
Yeah, I will. It's an ongoing, it's part of the reason why I keep pounding on this idea that, for Water Forum 2.0, I strongly urge us to maintain some budget to keep working with reclamation. We try really hard to make that a cooperative relationship and not an adversarial relationship. And I'm trying to say this as diplomatically as I can. Reclamation has multiple objectives and multiple stakeholders pulling them in a lot of different directions. Historically, frankly, other stakeholders have had, I think, a stronger pull than we have. South of Delta, the San Luis unit, Westlands Water District, has huge, huge clout. I think it's accurate to say that, going back 10 or 20 years, most folks that I knew who worked for the Bureau, and I was one of them during that period, saw that the objective, the reason for being of the Bureau was to deliver water south of the Delta, right? And they saw everybody north of the Delta as kind of an annoyance that they just had to deal with, right? That is slowly changing. And even in today's conversation, we lament sometimes that, hey, how come those Sac Valley guys seem to have so much political clout, right? They got Congress members on speed dial. They're coming up there for like a rice feed, right? For a rice dinner. And we have felt that in this tug of war over Folsom versus Sac Valley versus south of Delta. And we've made inroads, frankly. We've made real inroads, both in sort of the political voice. Again, I think that our testimony at WaterFix put us on a different put us into a playing field we weren't playing before. And we need to sort of maintain that. It's going to be an ongoing thing, and hopefully it doesn't become adversarial. There's a whole, you didn't ask this, Greg, but there's a whole other layer on this, which is how does the state board view this? During the drought, Tom Howard, executive officer at the state board, was really clear in talking to our region and the Sac Valley. Hey guys, when push comes to shove, there is a higher priority for delivery of water to cities than there is to rice farmers. So kind of like the urban folks in the Sacramento region have kind of been the hungry dog on the back porch, the redheaded stepchild, right? And I can say that because my wife actually has a redheaded stepchild, which is my daughter. And it's slowly changing, but we will have to continue to engage in that conversation.
Thanks. Before I go to some of the other hands that are up, just stick to the water caucus for a minute and just invite Dan or Tony, Jim, Paul. Anyone want to weigh in here with a thought and perspective on what this tells you about Water Forum 2, or any questions for Tom? Yeah, please, Tony.
It's been insightful for me to just hear all of this. I feel like I somehow intuitively knew about half of it, and Tom put it all together. And Tom, you're going to be very hard to replace. Thank you.
I just want you to know I didn't know Tony was going to say that when I called on him. Jim, I think I see you leaning forward.
Yeah, Bennett, thank you very much. I'll be real quick. I feel like this is really unfinished work that the Water Forum needs to engage in the water quality control plan. I believe that this region or this river has interests that we would need to include in that, either a VA or directly through the water quality control plan. And it's forever work, which I get a takeaway from what Tom is talking about.
Thanks. Let me just go over to the public caucus. Bill, Carrie, either you want to fold in here at all? Carrie.
Can you hear me?
Yep.
Okay, just checking. I don't have any questions. I love Tom's presentation. Thanks, Tom. I've seen flow standard presentations, I don't know, for many years, but every single time I learn something new. So I appreciate that. And I would just echo what Jim said. I think it's really important that this is forever work, and we continue to work to try to make this work within the water quality control plan process. So that's it.
And I'll just add that, yes, this is forever work and we're committed to do it. And it occurs to me, Tom, that this is one of the most critical things that need to be transferred to our new director, over the next year or so, is the critical importance of this work and the priority of it, and that it needs to continue to move forward. So
thanks, Bill. Jim, you're the voice for the business caucus here.
Yeah, I'd just like to say that was a great presentation, Tom, and like everyone else, I've learned something that I didn't know after being involved for 27 years. So thank you for that. I'm just wondering, for our caucus, if you could find some possible way to distill this down to kind of the cause, effect, and results in a very abbreviated presentation for our next meeting.
Great. Thanks. And let's go to the environmental caucus.
Jim, you're saying you guys aren't going to sit still for an hour and a half of blah 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 blah.
I'm afraid so.
Let's go to environmental caucus, and then we'll see if any of the other alternates in the mix want to fold in here. Ted, and then Clyde, and then.
Thank you. I too would agree with all the other comments, both regarding the presentation, the learning, and also the fact that this is a continuing mission we have to continue to invest in. I did have one question, and that had to do with SAFETA's plan to increase the height of Folsom and also some upstream dam heights for increased flood protection and storage, and whether that as a lever may have future implications for the standards effort.
The simple answer is yeah. We have those plans are conceptual, and so we don't have enough information about them to represent them in any of our modeling yet. But as I think I've included in the presentation after the break, yeah, the flood marsh stuff needs to be one of the things we look at in the future. And I can tell you, Tim Washburn and I have had a side conversation about this. He's very interested in coordinating more with what we're doing and his stuff. And I mean, he has made it really clear to me that his goal is not just to do no harm on the American, but to have a value add to whatever they're planning. So we got to get it in there. Haven't yet.
Good. Clyde.
Yeah, I'd just like to announce who the next executive officer is of the water forum. It's Tom Gohring. That's a very good presentation, Tom. I'd like to point out that the minimum flow standard for the river is, in fact, that it is a minimum. It's not what the river needs all the time. It's just sort of the minimum. It's kind of like when you come down with COVID and you go to the hospital and they say, gee, we're jammed up. We got people all over the place, and we'd like to give you 100% oxygen, but we can't. But we're going to give you 10%, and we hope you survive. And so that's kind of that's what's really going on. The Bureau has a lot of water over and above the minimum flow standard a lot of the time, and I think if you remember at times we get down to 500 CFS, and Tom showed a picture of that early in his presentation. And, that's not what the 500 CFS is not what the fish need. And so anyway, it's a minimum and not what they need, but anyway, that's what I want to say.
Okay, next slide. Ron.
I want to reflect on perhaps negotiating issues about the FMS. When we created the FMS proposal, at least in its first incarnation in 2000, with antecedents to 1998, we contemplated that there would be a resolution of this in 2002, which is now 18 years ago. And there hasn't been a resolution of this in those intervening 20 years. We contemplated that perhaps in good faith, in incredible naivete, and we told the executive director that it was cool to work on the FMS, taking habitat management element funds that had been raised for essentially physical improvements in habitat and recreation, either at Folsom Reservoir or more, or the weight of it would be in the Lower American River, and dedicate that to the development of a flow standard and the advocacy of a flow standard. And I think that has that at least a fair amount of that work has been booked to the HME program ever since. Now, Tom could give us a better sense of the relative weight of that in the HME program. The HME program essentially has the contributions from water purveyors, particularly the city of Sacramento and the county of Sacramento. And it's been augmented by restoration funds from CVP contractors and whatever odd grants it can pick up. But it's, the core kind of intellectual exercise work for that has been, I think, booked coming out of the HME accounts, which have somewhat more stability than a grant or even Restoration Act funds, which could go to various projects throughout the CVP and areas not in the CVP. So, I bring this up because there's been a recognition that we were naive in thinking that we could actually get the FMS done in 2 years, and here 20 years from now, we're talking about a 3-year pilot project to implement parts of it for the next 3 years. So, and I think more importantly, I think that what this program has become is essentially a forever program, recognizing that this region is in conflict, though it may not be always open conflict or complete conflict, but fundamentally in conflict with other regions that draw upon this common river heritage coming down into the delta from either the San Joaquin side or from the Sacramento side or the McCollum side. And the Cosumnes Rivers is a tributary of the Cosumnes, or sorry, the McCollum. So what in effect the water forum has become is an adjunct to regional struggles vis-a-vis other regions, which will never end. I mean, there's no final resolution to this, and the water forum has been one of the institutions that has risen to represent this region on the backs of a funding source that was supposed to be devoted to other things, at least as it was conceived. So if you're, I mean, the reason why I go on and on about this is that concept really needs to be understood, I think, by the whole negotiating committee, because it has a bearing on a number of issues, including, who's bearing the financial burden of the water forum, and what accounts we're drawing on for these ongoing regional efforts, which you might just call regional defense or regional efforts to maintain regional amenities, however you want to call it. It's become much more than it was conceived of in 2000 when the water forum agreement was signed.
Ron, I'm gonna jump in here in a sec.
I'm done.
Okay, thank you. We should be pushing forward. Jim, I see your hand went back up.
I want it, in the sake of time, I'm gonna withdraw my raising my hand. I do want to come back to what Ron is talking about sometime and better understand that.
Okay.
And what the issue is.
Which particular part, Jim? You wanted to make
Ron
sure.
said a lot there, and I think it crossed. I'll just be real quick about this. Ron has brought up that there was a long-time commitment embedded in the original water forum, which was supposed to be completed around 2001 with the adoption of the flow management standard. And I think we need to come back to that. And that's, I'll just say something that's really uncomfortable to say. It's probably not going to happen if it hasn't happened yet. So we need to figure out what plan B is. And I think that's something that needs to have additional conversation. But I think Ron also talked about how, if I understood this correctly, trying to implement the flow management standard has taken resources from different buckets, and it has reprioritized things and kind of reprioritized the work in a messy way with the water forum. And I think that this needs a little bit more, if I understand that correctly. And I think that this is a discussion item also. And that's all I want to say.
Okay, thanks. And I think we should let that sit there and we'll figure out a way to bring that back. Thanks. A couple of comments in the chat from alternates, Paul and Barbara, both Barbara Leary weighing in on how helpful this presentation has been. But I do want to see if there were any other alternates that wanted to weigh in, and then we'll get to a break here. If not, thank you, Tom, for the presentation, and thanks for the comments here. I clearly, you know, that forever aspect and raising the region's voice and profile and sort of being mindful of the dials that you're controlling and not seems something to carry forward here.